Question number 9. A ball of mass M moving with speed v strikes a hard wall at an angle theta with the wall. It reflects with the same speed at the same angle as shown in the figure below. This is the direction of the ball. Strike here. And this is the ball and reflector back here. Then you have theta. You have theta. Okay, we need to find the components. Here we have the direction of the ball is in this way. The components for the incident one. So we have V as sine theta, which is the x component, V cos theta, which is the y component, and likewise we need to find the component after bouncing. So we have V sine theta, the same value, but in the left direction, V cos theta in the y direction. So one is positive, the other is negative. To the right, you can take that is positive. To the left, it's possible to take as negative. Okay, so we know that Ft is equal to the impulse is equal to change in momentum, which is mv final minus mv initial. So F times T is equal to mass multiplied by V final. We can refer this one. Okay, this is the V final, and this is also the V initial. Remember, one is positive, the other is negative. This is positive, and this one is negative. Okay, so having this in mind, now let's go back and V final is V sine theta, and V initial, which is V sine theta. But this is positive, the other is negative. But for convenience, it's possible to take the left one positive, the other negative. It doesn't have any problem. So for this case, so we have to take the summation in general. It becomes 2 times m times v times sine theta. Let's rewrite the result. Okay, from this consideration, mv sine theta plus mv sine theta. Okay, so 2 times mv sine theta. It's possible to take also the minus sign, so 2 times mv sine theta divided by t. So this is a representation of the force. You can write like 2 mv over t times sine theta. So the answer is D. Okay, so let's proceed to the other question. Question number 10. According to work energy theorem, the work done by a tension on an object tied to string moving in horizontal direction is force. We have the force, then work is the dot product of force and displacement, but they are 90 degrees with each other. So we have equal speed now, change of direction only. So in this case we have a 0 result, so we don't need to consider the other relation. Now let's proceed to B. So alternative B says work done by a gravity on an object thrown downward is negative, but in downward direction, when it goes downward, the velocity will increase. So an increase in velocity will give you a positive result, not a negative result, because 1 over mv final minus 1 over 2 mv initial. So the final is larger than the initial, so we have a positive result, not a negative result according to this relation. Okay, now proceed to the C. Work done by gravity on an object thrown upward and moving upward is negative. Yeah. So D. Work done by gravitational force on a satellite moving around the Earth in a circular orbit is positive. Likewise, this has also 0 results, so the answer for this question is C. Okay, so now let's proceed to question number 11. Question number 11, standing wave is for when two identical waves traveling in opposite direction in the same medium interfere with each other. If y1 and y2 are the waves, then y is equal to y1 plus y2. We have two y's. First one is y1, second one is y2. Let's write y1 a times sine kx minus omega t, and y2 will become plus y2 in b because they are moving in opposite direction. A sine kx plus omega t. Okay, now let's find y is equal to y1 plus y2. We have two y's. Okay, so y is equal to, for y1 we have a sine kx minus omega t and plus a sine kx plus omega t. One is for y1, the other is for y2. Okay, so a is common, so it's possible to write outside. So inside brace we have sine kx minus omega t plus sine kx plus omega t. So using trigonometry, kx can be replaced by a, omega t with b, which means sine a plus b is equal to sine of a cosine of b plus sine of b cosine of a. Likewise, sine a minus b is equal to sine of a multiplied by cosine of b, but here we have minus sign, so we have to put minus sine of b cosine of a. Okay, so one is when you add them together, sine a plus b minus, so this cancel out, one is plus, the other is minus, that's why this cancel out. So left with 2. So sine kx, which is sine of a, minus omega t, sine of b, sine kx plus omega t, sine a minus b, sine a plus b, just like before. So we have 2 times sine kx cos cos omega t, because the other is cancel out, one is positive, the other is negative, that's why we write like this. This cancel out, plus and minus, so we have sine a cos b, and here also we have sine a cos b, so when you add them together you get 2 times sine a cos b. A is kx, b means omega t, so 2 times sine kx cos omega t. So we left with this, so we have a is common outside. So when we write this again, what do we get? We have this, so we have to put a here, so we will get 2 times a. That's right, y is equal to y1 plus y2, which is a2 sine kx cos omega t. This will be equal to 2 times a sine kx cos omega t. So from the question, we have b to a sine kx, b is to a sine kx cos c also like that, but the correct answer is B.